Welcome to Astronomy Daily, your daily dose of the latest and most exciting news from across the cosmos. I'm Anna.
And I'm Avery. We are so glad to have you join us as we dive deep into the fascinating world of space and astronomy. There's always something incredible happening out there, and we're here to break it all down for you.
Today, we're covering everything from a historic, yet brief, rocket launch in Australia to NASA's latest lunar mission contracts and an exciting new radio telescope preparing for its journey to the moon's far side.
Plus, we'll get an update on SpaceX's Starship as it gears up for its 10th flight. So get ready to explore the universe with us.
Kicking off our news, we have an update from Australia, where Gilmour Space made a historic attempt at their first orbital launch. On July 29th, their Eris rocket lifted off from the Bowen Orbital Spaceport in Queensland, marking Australia's first homegrown orbital launch attempt in over 50 years.
That's a huge milestone for Australia's space industry, even though the launch didn't go as planned. Just 14 seconds after liftoff, the Eris rocket began sliding sideways and crashed back to Earth. It sounds reminiscent of Astra's third orbital launch attempt back in 2021, which also had a similar sideways slide.
Exactly. It's a tough break for a debut, but Gilmour Space is maintaining an incredibly optimistic outlook. They shared on X, formerly Twitter, that Eris became the first Australian-made orbital rocket to launch from Australian soil, achieving 14 seconds of flight and a 23-second engine burn. They called it a big step for launch capability, confirming their team was safe, data was in hand, and their eyes are already on test flight 2.
It really highlights the fail fast, learn faster mantra of the space industry. Gilmour Space CEO Adam Gilmour emphasized that every second of flight will deliver valuable data that will improve our rocket's reliability and performance for future launches. He also stated that getting off the pad and into flight is a huge step forward for any new rocket program, proving that much of what they've built works. It's fantastic that there were no injuries or adverse environmental impacts. This launch has been a long time coming for them. Gilmour Space, based on Australia's Gold Coast, initially aimed for a March launch, but that was scuttled by Tropical Cyclone Alfred. Then, a mid-May attempt was foiled by a technical issue where Eris's payload fairing unexpectedly popped off while the rocket was on the pad. Oh wow, a power surge caused by electrical backfeed from downstream devices was the culprit there. After fixing that, they geared up for late June, but strong winds at the spaceport, which Gilmour Space operates, pushed it back further. It seems like a combination of weather and technical glitches kept pushing the date until they finally got off the ground.
It truly was a testament to their persistence. The company, founded by Adam and James Gilmour in 2015, aims to make Australia a major player in spaceflight. Eris, their 82-foot-tall rocket, is designed to launch payloads of up to 474 pounds to sun-synchronous orbit.
And it's not just rockets. The company also built satellites. Their Erisat spacecraft bus had its first launch just last month on SpaceX's Transporter 14 mission, carrying in instruments for CSIRO, Australia's national science agency, to monitor water quality. So while the Eris launch didn't fully succeed this time, it's clear Gilmour Space is a significant and growing force in the Australian space sector.
Next up, let's turn our attention to some exciting news from NASA and their ongoing Artemis campaign, which is all about exploring more of the moon than ever before. NASA has recently awarded a substantial contract to Firefly Aerospace, based in Cedar Park, Texas.
It's a big step, and what's particularly noteworthy about this delivery is that it's the first time NASA will use multiple rovers and a variety of stationary instruments in a truly collaborative effort. They're working with the Canadian Space Agency, or CSA, and the University of Bern in Switzerland.
It's a big step. And what's particularly noteworthy about this delivery is that it's the first time NASA will use multiple rovers and a variety of stationary instruments in a truly collaborative effort. They're working with the Canadian Space Agency, or CSA, and the University of Bern in Switzerland. The primary goal is to gain a deeper understanding of the chemical composition of the lunar South Pole region. This area is of high interest due to the potential for using resources available in its permanently shadowed regions, which are thought to hold water ice. Joel Kearns, NASA's Deputy Associate Administrator for Exploration, highlighted that CLPS is embracing a new era of lunar exploration, with commercial companies like Firefly leading the way. These investigations are crucial for developing the knowledge needed for long-term sustainability on the moon.
And the instruments they'll be carrying are fascinating. One of the rovers is Moon Ranger, an autonomous micro rover developed by NASA's Ames Research Center and Carnegie Mellon University, which will explore the lunar surface and study hydrogen-bearing volatiles with its neutron spectrometer system.
Then there are the stereo cameras for lunar plume surface studies, designed to capture the impact of the rocket exhaust plume as the lander descends, helping us predict lunar regolith erosion. We'll also see a laser retro reflector array, a passive instrument that will serve as a permanent location marker for decades.
The CSA rover is also part of this mission, specifically designed to access and explore remote South Pole areas, including those permanently shadowed regions. It's built to survive at least one lunar night, carrying a suite of instruments like stereo cameras, a neutron spectrometer, and the thermal imaging radiometer to understand the lunar surface, geological history, and potential resources like water ice. And finally, the University of Bern is contributing a laser ionization mass spectrometer. This instrument will analyze the element and isotope composition of lunar regolith, using a robotic arm and titanium shovel to excavate samples. It'll give us grain-by-grain analyses to understand the chemical complexity of the landing site and the moon's evolution. It's a comprehensive set of tools aimed at unlocking the secrets of the lunar South Pole.
From potential lunar resources, let's shift our focus to an ambitious scientific endeavor, listening to the very early universe. The Lunar Surface Electromagnetics Experiment Night Radio Telescope project has reached a major milestone and is now ready for testing.
This is incredibly exciting, Anna. This project plans to deploy a radio telescope on the moon's far side by 2026. The unique advantage of the moon's far side is that it's completely shielded from Earth's radio noise, which constantly interferes with ground-based telescopes.
That isolation is key, isn't it? It allows Lucy Knight to search for incredibly faint signals from the early universe, specifically the coveted Dark Ages signal. This signal originates from a time when the universe was only about 380,000 years old, long before the first stars and planets had even formed. Earth's radio interference typically drowns out this specific signal, making a far-side lunar telescope an ideal location.
Absolutely. But as appealing as the far side is for its radio quietness, it presents immense engineering challenges. Any equipment sent there has to contend with an incredibly harsh environment. We're talking about massive amounts of radiation and extreme temperature swings.
And when we say extreme, we mean it. Temperatures can drop to minus 173 degrees Celsius during the 14-day lunar night and soar to 173 degrees Celsius during the 14-day lunar day. This day-night cycle also means that if the system relies on solar panels, it needs to power itself for 2 weeks without recharging.
That's where the design gets intricate. A significant portion of the telescope's weight, about 50 kilograms, is dedicated solely to its battery to ensure it can last through 2 weeks without sunlight. Beyond power, thermal management is another huge hurdle. UC Berkeley designed a specialized heat pipe system that transfers heat generated by solar radiation and the instruments to a radiator, which then releases that heat into space.
They also incorporated a series of thermal switches to control the internal temperature and turn subsystems on and off as needed to maintain thermal stability. What's particularly ambitious about Lucy E. Knight is its objective to collect data 100% of the time, which demands a complex melding of power and thermal management.
It truly is. While collecting dark age data is a significant goal, Lucy E-Night's primary mission is actually a technology demonstration. It's designed to prove that radio telescopes can not only survive, but also viably collect data on the far side of the moon for more than just a few days. The plan is for it to collect data for over 2 years. If successful, it will pave the way for even more powerful radio telescopes in this uniquely quiet region of space.
From the quiet far side of the moon, let's now turn our attention back to Earth, or rather, just above it, with some news from SpaceX. They've recently moved their Starship vehicle to the launch pad for testing ahead of what's expected to be its 10th flight.
That's right, Anna. This is a big step for the ambitious program. Flight 10 is anticipated to take place next month from SpaceX's Starbase site in South Texas. The Starship upper stage, which stands at 171 feet tall, was documented making its journey to the pad in photos shared by SpaceX.
Elon Musk initially hinted at a launch in about 3 weeks, back on July 14th, and his most recent update points to next month, so we're definitely nearing another launch attempt. SpaceX is developing Starship as the largest and most powerful rocket ever built, with the ultimate goal of helping humanity colonize Mars and undertaking other significant exploration feats.
This vehicle is quite a marvel, consisting of 2 fully reusable elements, the giant Super Heavy booster and the upper stage spacecraft, often referred to simply as ship. While the Super Heavy booster has shown remarkable success in its recent flights, even demonstrating the chopstick catch by the launch tower, the ship upper stage has faced its share of challenges.
Indeed, SpaceX lost the ship vehicle on the 3 most recent Starship flights, which took place in January, March, and May of this year. They've been diligently working through issues, including a rapid, unscheduled disassembly of a previous ship variant on a test stand in June, which was traced to a pressurized nitrogen tank failure.
It's clear they're learning and adapting with each test. Despite these setbacks, the drive behind Starship remains focused on its grand vision, enabling routine, fully reusable spaceflight to make Mars settlement economically feasible. All eyes will certainly be on Flight 10 to see how these ongoing improvements play out.
And that brings us to the end of another fascinating episode of Astronomy Daily. We've covered quite a range of stories today, from the challenges of Australia's first orbital rocket launch attempt with Gilmour Space's Eris to NASA's significant new contract with Firefly Aerospace for lunar deliveries.
Yes, and we also looked at the incredible potential of the Lucy E-Night radio telescope preparing for its journey to the moon's far side, hoping to unlock secrets from the universe's dark ages. And then, of course, the continuous development and testing of SpaceX's mighty Starship as it inches closer to its ambitious goals.
It's been a packed episode full of the latest advancements, some setbacks, and incredible leaps in space and astronomy. There's always so much happening in the cosmos. And if you'd like to keep across even more space and astronomy news, just visit our website at astronomydaily.io.
Absolutely. Thank you so much for joining us on Astronomy Daily. We love sharing these updates with you.
Be sure to tune in again tomorrow for more exciting space and astronomy news. Until then, keep looking up.